Bright Tuty. Every student matters.
Now to simplify this, that how to locate a point in a two-dimensional space or in a plane, the mathematician Descartes devised a system, okay, which is known as Cartesian coordinate system, or in short form Cartesian system. Okay, what he suggested or what he came out with is that if you have got two perpendicular lines, one can be horizontal, another can be vertical. Now it is not necessary that they are horizontal and vertical, they can be any sort of lines, but they should be perpendicular to each other, so mutually perpendicular. So even if you have these two lines, these will also work to locate a point or for the Cartesian coordinate system. And if you take this as a point, let us say O, right? Now you can locate a point in two-dimensional space or in plane. What do I mean by plane? You see your paper that you have, with the paper you are writing it on, okay, that is a two-dimensional space or two-dimensional paper. Okay, so if you want to locate a point in two-dimensional space, now you can do that in three-dimensional space also. When I say three-dimensional, I mean this room, right? If you want to locate a point in this room, let us say you want to locate this point here, you can do that using Cartesian coordinate system also, but right now we are studying only two coordinates system, right? So now Cartesian made it simple for us to locate a point using these lines as our reference lines, these mutually perpendicular lines. So the lines, if you draw any one line and another line which is perpendicular to it, that system will be known as Cartesian coordinate system. Okay, but we will use these two mutually perpendicular lines, out of which one is horizontal, another one is vertical, right? So a horizontal line and a vertical line crossing it. Okay, the point where they intersect each other is known as origin. Okay, and we can denote it by y, y dash, x dash. So there are these two lines, x dash o x and y o y dash, right? So I have taken these two mutually perpendicular lines, right, and they intersect each other at this point, which is origin. We will call it origin from now on, right? Now we can divide these lines in suitable scales, that similarly to what we did in previous question, right, to locate a certain point. Let us say we divide it into units of 1 centimeter. This is 1 centimeter, right? So this is also 1 centimeter and so on. Similarly, we can divide this also in 1 centimeter gaps. Okay, now we can locate a certain point using this data. Let me tell you some more things about it. Similar to the number line, this horizontal line will have 0, 1, 2, 3, 4 and so on. On the left side of the 0, I will have -1, -2, -3. Okay, I have drawn this x dash ox line here. Okay, from now onwards we will refer it to as x axis, right? So this is origin, which I have taken 0 here. So on the left of origin we will have negative numbers, on the right of origin we will have positive number. So this is positive direction of x-axis, positive direction of x-axis, and this is negative direction of x-axis. Okay, similar way we can say that this vertical line, if this is 0, right, while going upwards we will have positive numbers 1, 2, 3 and so on. So this is, if this was y o y dash line, right, we will call it y axis from now on. Okay, so going upwards or the points above origin are positive, right? So this is positive direction of y axis, positive direction of y axis, and going downwards or below 0 we will have negative numbers, so that -1, -2, -3 and so on. So this is known as negative direction of y axis. This is known as negative direction of y axis. Okay. Now, if I draw these two lines collectively, okay, these two lines, and these will intersect at the point O that we've taken, right? This is our origin. Now this system, let me name it. This is x, this is x dash, this is y, this is y dash, and this is positive direction of x-axis. This is negative direction of x-axis. These divisions that I am making, you can take a suitable scale for them. Let us say you have divided this line in divisions of 1 centimeter or in gaps of 1 centimeter. You can take any scale, right? You can make a map of entire state, and then you can give a suitable scale to it, that 1 centimeter is equal to 10 kilometer, let us say. Okay. So these are divisions of 1 centimeter each on x-axis. Similarly, on y-axis, upwards direction, we will have positive direction of y-axis, so 1, 2, 3, 4 and so on. Downwards, we will have negative direction of y-axis, so negative numbers will be here. Okay. So these are two number lines, you can say, right? These are kind of number lines. One is vertical and another is horizontal. Why we have taken it like that? To describe a position of a point or something else in a two-dimensional space, or we call it plane. When I am saying two-dimensional space, I mean plane. What is a plane? The paper or the notebook that you are writing it on, the piece of paper, that is two-dimensional space, right? If you want to locate a point, you just need one dimension in horizontal direction and one in vertical direction, right? All right. So this is how we will divide it. Now this system is known as axes, right? I have used E here, right? This is coordinate axes, or you can say Cartesian coordinate system, Cartesian coordinate system, Cartesian coordinate axes, or we call them rectangular axes also, rectangular axes. Why rectangular? Because this angle is a right angle here, that is why this word rectangular axes. Okay, and take care that I am writing E here, so I am writing both the axis, x axis, y axis, collectively are coordinate axis, right, or rectangular axes. So this is about rectangular axes that Descartes suggested, and this is really useful in locating a point in two-dimensional space or in a plane. Okay. Now you can notice that these two lines, these two mutually perpendicular lines, are dividing this plane in 4 parts, right? In 4 parts. What do I mean? This line will continue in this direction, right? So when I am making this arrow mark here, this is not ending here, right? It continues after that also. That is the significance of this arrow mark, and this will continue in this direction. Okay. Similarly, this will continue and this will continue in this direction. Now you can see that these two mutually perpendicular lines have divided this plane in 4 parts. right? What are those 4 parts? This part, this one, and this one. These 4 parts are known as quadrants, right? These are known as quadrants, and by convention we call it first quadrant. This is first quadrant. When I say Q, I mean quadrant here. This is second quadrant. This one is third quadrant, and this is fourth quadrant, right? So the two mutually perpendicular lines divide the entire plane in 4 parts, and these 4 parts are known as quadrants. And I have told you the convention that this part, which is, if I denote it by x, o, y, this x, o, y, right? So this is my first quadrant, and this part x dash o y is second quadrant. Similarly, x dash o y dash is third quadrant, and x o y dash is fourth quadrant, right? Now you tell me, let me make this coordinate axes or rectangular axes once again. So these arrow marks are important, and then you write x, o for origin, x dash, y, y dash. This is positive direction of x-axis. This is positive direction of y-axis. This is negative direction of x-axis. And this is negative direction of y-axis, right? Now you tell me, if I want to reach at a point which is 2 centimeters towards right and 3 centimeters above this point here, right? 2 centimeters towards right and 3 centimeters above. These gaps or these divisions I have made of 1 centimeter each. So 2 centimeters towards right and 3 centimeters above. Now I will raise a perpendicular line here, or a line parallel to this y-axis, and I will draw a line parallel to x-axis also. These lines will meet at a point. Now this point, if you look from the x-axis or in horizontal direction, it is 2 centimeters away from y-axis, right? And it is 3 centimeters away from the x-axis, right? In vertical direction, obviously. So this point here is known as 2, 3, and these are the coordinates of this point. If this point is A, then I will say coordinates of point A are 2, 3. This is how the coordinates are written, right? We use this open bracket and write the coordinates like this. For example, in this case I have written 2, 3. Now this 2 means x coordinate, and this 3 means y coordinate. Why can't I write y coordinate first and x coordinate second? Because this is a convention, right? We have to go by a convention so that internationally we are following the same convention. Otherwise there will be huge confusion, right? Some mathematician will write y coordinate first and x coordinate second, and some will write x coordinate first and y coordinate second. Then it will cause a huge confusion. So that's why these conventions in mathematics are given. So first coordinate that you write in this bracket is x coordinate, then you write this comma, and then y coordinate. Okay, this will mean you go in the x direction, right? Towards left or right will depend on its sign. In this case it is positive, so you will go towards right, that is in positive direction of x-axis. And here y coordinate is also positive, so you will go in positive direction of y-axis. So we went in positive direction of x-axis, then in positive direction of y-axis, and reached at this point 2, 3. Similarly, if I am given another point, let us say -3, 5. Now this is my x coordinate and this is y coordinate. So it suggests me that I need to go 3 units in the x direction but in negative x direction, right? So 3 units in the negative x direction and 5 units in positive y direction. So let it be 5. So 5 units in the positive y direction. It will reach at this point. We will reach at this point here, which will be minus 3 comma 5. Okay. So the first coordinate that is written in this bracket will suggest how much distance we need to cover in x direction. Depending on sign, whether we go in the, depending on the sign, we will go in the negative x direction or positive y direction. Depending on the sign, we will choose the direction, whether we need to go in the negative direction of x-axis or positive direction of x-axis. The first coordinate, let us write it small x. And second coordinate, if I write it small y, will tell me how much distance I have to travel or how much steps or how much units I have to go in y direction. And depending on its sign, I need to decide whether I need to go in positive y direction or negative y direction, right? If the sign is positive, then positive y direction. If the sign is negative, then negative y direction, right? Look at a point, let us say 2 comma minus 3. So now I have to go, in this case I have taken 1 centimeter as unit on each axis, right? So I have to go 2 centimeter or 2 units in x direction. Which x direction? Positive x direction. And 3 centimeters in y direction, positive or negative? In obviously negative y direction. So 2 centimeter in positive x direction and 3 centimeters in negative y direction. So I'll reach here at this point, that is 2 comma minus 3. Okay. Similarly, we can take another example, minus 1 comma minus 3, let us say. So I have to go 1 unit in negative x direction and 3 units in negative y direction. So 1 unit in negative x direction and 3 units in negative y direction. So I'll reach here, which is minus 1 minus 3. Okay. I hope you can now locate a point in Cartesian coordinate system, right? And you have understood about quadrants also. So let me tell you one more interesting thing about quadrants, that is known as sign convention. Sign. Let us say this is 1, this is 2, this is 3, this is 4, and so on. Minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2. This is x dash, this is y dash, and this is the origin. Okay. Now, if I have to locate a point here, this is my first quadrant. If I have to locate this point here, I need to go in positive x direction, right? Starting from origin, I have to go here, and then in positive direction, positive y direction, right? So I'll reach a point at this point. So x coordinate will be positive and y coordinate will also be positive. Why? Because to reach at this point, I need to go in positive x direction first and then positive y direction. So positive, positive. So both the coordinates, x coordinate and y coordinate, are positive in this case. In first quadrant. In second quadrant, if there is a point, I need to go in negative x direction and then positive y direction to reach at this point. So negative x direction and positive y direction will mean the x coordinate is negative, y coordinate is positive. Why am I going in x direction first? Because of the convention that the first coordinate is x coordinate and the second coordinate written in this bracket is y coordinate. So I am going in x direction first and then y direction. To reach at a point in third quadrant, this was in second quadrant, right? Second quadrant. In third quadrant, I have to go in negative x direction and then negative y direction. So both the coordinates x and y are negative in this case. So this is negative, this is also negative. So in third quadrant x and y coordinates both are negative. In fourth quadrant, if I have a point, I have to go in positive x direction and then negative y direction. So x coordinate will be positive, y coordinate will be negative in fourth quadrant. Okay. So if I have to write it, first quadrant, positive, positive. This is x coordinate and this is y coordinate. Okay. X coordinate is positive, y coordinate is also positive. In second quadrant, x coordinate is negative, y coordinate is positive. In third quadrant, x coordinate is negative as well as y coordinate is negative. Let me separate them by a comma. Okay. In fourth quadrant, x coordinate is positive and y coordinate is negative. Okay. So these are the signs of coordinates in various quadrants, first, second and third and fourth quadrant, right? Now when I am saying 1, 2, 3, let us say this is x, this is -1, -2, this is x dash, this is y, this is y dash. When I am saying that I need to go or I need to locate a point 2, 3, right? So what we have learned that we will go 2 units in the x direction, in this case positive x direction, and 3 units in positive y direction, and we will reach at this point 2, 3, right? So now what you can say about this x coordinate here? We are going 2 units in this direction, right? So this is y axis, this is y axis. I can also say that it is 2 units away from y axis, right? 2 units away from y axis, and this is 3 units away from x axis. This is x axis, this is x axis, and this point is 3 units away from x axis. Now I need to make this statement in one sentence, right? That the point 2, 3 is 2 units away from y axis and 3 units away from x axis, and is there, right? Okay, so the x coordinate here, x coordinate gives me distance from y axis, and y coordinate gives me distance from x axis, or you can say other way around, that x coordinate is the distance from y axis and y coordinate is the distance from x axis. Now the distance cannot be negative, but x coordinate and y coordinates can be negative depending on the direction we are going. Okay, one thing. Okay, x coordinate is distance from y axis. Now some of the students may say that this distance, I am saying that this is the distance from y axis. Some of the students may say that this is also the distance of this point, this is also the distance from y axis. But no, when I say distance from y axis, let us say, if I say that this point and this line, if I say what is the distance of this point from this line, will you measure this distance, or this perpendicular distance? Obviously this distance is the distance between this point and this line, so we will measure this perpendicular distance. Okay, so what I have done is I have taken this point and dropped perpendicular on y axis and x axis, then show the distances. Okay, now this x coordinate will give me distance from y axis, y coordinate will give me distance from x axis, and the signs of coordinates will give me the direction, whether it is in the negative direction of x axis or negative direction of y axis or the other directions. Okay, and this is also known as this distance is also known as abscissa, right? Distance in x direction is also known as abscissa, and in y direction it is also known as ordinate. For example, for this point, abscissa is 2 and ordinate is 3. And if I take another point, minus 2 comma, let us take minus 2. So negative 2, negative 2. So this point is minus 2, minus 2, right? Now look at this. What is abscissa? Abscissa is minus 2. So abscissa and ordinate will have the signs also in them, right? So abscissa is minus 2, ordinate is minus 2. You will not say that abscissa is 2, right, without the sign. No, you have to mention the sign also. When you say abscissa is 2, that means the distance of the point in x direction is negative 2, or you can say other way around, that the point is towards the negative direction of x-axis and 2 units away from y-axis. Okay, because x coordinate gives me the distance from y-axis, right? Now what about origin? What are the coordinates of origin? What is the distance of this point from x-axis? 0. What is the distance of this point from y-axis? 0, right? So this coordinate of origin are 0, 0. Okay. Now let me tell you one interesting thing. If you have got any point on x-axis, then what will be the distance from x-axis? If you have got any point on x-axis, what is the distance? What is the distance of this point from x-axis? Obviously 0, right? So the y coordinate, hence y coordinate of any point lying on x-axis will be 0. So any point lying on x-axis will be of the form x, 0. There will definitely be an x coordinate, but y coordinate will be 0. Using the similar logic, you can say any point on y-axis will have x coordinate as 0. So 0, y. Any point on y-axis will be of this type, 0, y. Okay. Why? Because the distance of this point or any point lying on the y-axis is 0 from y-axis. Distance from y-axis of any point on y-axis is 0. That is why the x coordinate of the points lying on y-axis will be 0.